In this video, we're going to explore different energy sources. Look at the source-specific advantages and disadvantages for each of the different power sources that we rely on. We're going to look at coal, we're going to look at natural gas, and we're going to look at nuclear energy for the purposes of this examination. So, start with fossil fuels in general. They're still popular for power generation. Natural gas and coal, they're the two we're going to look at today. The big question, though, why is coal lumped in there? Coal just seems such an archaic and antique fuel to still be using. Yet it does provide a lot of electricity here in North America. So what's going on with that? Well, when we look at where coal reserves are around the world, a lot of them are in North America. An old political anecdote, it's North America is the Saudi Arabia of coal, what they really mean, because the Middle East, Saudi Arabia, has such big reserves of oil, crude oil. Well, North America is much the same, but their endowment is in coal resources. Top coal producing countries: China, the United States of America, and really nobody else is on the map. China's leading the way, and the United States of America, very productive coal industry. There's just not a huge there's been a shift away from more labor-intensive coal mining in the United States just because of the cost. When we look at the global share of consumption, we see some patterns that are very interesting. The one thing we note that there's still a huge demand for coal. And what these circles represent is the lighter shade of purple was the global share of consumption in the year 2000. And the darker purple circles are the same share of global consumption 15 years later. And so we see the United States, or at least North America anyway, that's declined. There's been a bit of a decline in North America. Same with Europe. However, Asia, this is largely driven by India and China, seen a huge increase. So right now that's why we see such a big focus on coal production from China. That's because a lot of their demand is really eating up that supply. Here's the world coal reserves again, just a slightly different graphic. There is a lot of coal available. So even though it's a non-renewable resource, it's pretty plentiful. So when we look at domestic U.S. coal production, it is localized. It's called the Western region, Powder River Basin, interior, and then the Appalachian region, in sort of the mountains of West Virginia and Pennsylvania. And so each one of these has slightly different kinds of coal. Some of it's cleaner burning than others. And so there's different regional restrictions that try and advantage their own home producers. So pros and cons. What's good about coal? It's cheap. It's reliable. You essentially just dig it out of the ground, put it on a train, and it's where it needs to be within hours or days. Very high energy yield, and it's easy to burn. So all those things make coal just a real winner, especially for the Americans. Cons: it is technically a non-renewable resource. Even though there's so much of it, it will eventually run out. It's very high polluting. It is very high polluting. China has a booming economy with large coal reserves and large coal production. They've also got very poor air quality in some of their big industrial cities. Now there's been a shift away from that in recent years, especially coming into 2016, 2017, starting to shift away because of that air quality, but high pollution is a concern. Also, pretty dangerous. The mining of it, we look in Latin America and in Asia, there are lots of coal mining disasters. They're all too frequent to see hundreds of people losing their lives at a time. So it's not really a great fuel on those fronts. What about oil and gas in general? Again, we see the global distribution here. Lots of North America, Central South America, but the bulk of it being held in the Middle East. Now, the Americans are actually pretty good in terms of total liquids because they are producing natural gas from shale, and they've turned into, in recent years, a total exporter, which we'll come to in a bit. But really, the takeaway here is that a lot of these resources are localized in a few places. So natural gas, what's good about it? Well, pros for the Americans, they like having a domestic supply. It's also a return on investment for existing sites. The process they use called fracking is what it allows them to do is get more stuff out of things that they've already invested in. That's what they mean by return on investment for existing sites. So after oil wells have already been depleted, you can get in there with some technologies and actually get natural gas out of some of the shale formations around there. Air quality, gas is cleaner burning than coal, which is a good thing. And it's also lower price for fuel and overall price of food. Cons, transportation, just like oil. Oil is messy to transport. Oil spills, pipeline explosions, those are way too common. Same thing for natural gas. Natural gas leaks, harder to contain. And does pose some logistical problems transporting it. There's pollution, there's underground earthquakes, methane leaks, water contamination, all these things can happen. Can be pretty noisy when you're mining for natural gas, especially when you're using fracking and other new techniques. So it's got its ups and downs as well. Nuclear energy, not really a fossil fuel, but it's one of the important fuel sources in North America, and it's worth discussing because nuclear energy had so much potential. In the 1950s, people were predicting that it would someday supply 20% of the world's commercial energy. But it's been 50 years, massive government subsidies, massive private investment as well. We're at 6%. Since 1975, the number of reactors has even declined. And even in Europe, where nuclear power is such a large source for their domestic needs. So people aren't loving the nuclear. Why is that? Well, there's plenty of good things. For one, lower CO2 emissions overall, almost zero. Lower operating costs. It doesn't cost much to operate once you've built one of these things. Domestic supply, at least in North America, Canada, big supplier of uranium. So we've got the resources here. The waste can be reprocessed. Some of the spent fuel rods can actually be shipped around the world to the United States, to Russia, to help repurpose and use in their own reactors. So there's lots of options available. Those options aren't all good, though. Just some of the negatives. High fixed costs. Even though there's lower operating costs, it costs an enormous amount to build it in the first place. So if you can afford to build one, it's not that much to operate it once you get it going, but it's really hard to build it in the first place. And it takes a while. It can take decades to finish a nuclear project. Speaking of decades, centuries even, the waste lasts forever. So what waste can't be reprocessed, you got to do something with it. You bury it in the ground, you bury it in an old mine shaft, and it sits there polluting with radiation for 5,000 years. So that's not good. And that's very political here in southwestern Ontario and across the border of Michigan, because there's always talk of what to do with our spent nuclear waste. Where do we want to bury it? And obviously nobody wants it buried near them. There's security concerns with weaponized uranium and people trying to access and steal spent fuel rods and nuclear material. And then frankly, it's just dangerous. Even though there are way more people killed in coal mining accidents, the threat and the potential devastation from nuclear accidents is far greater. There's been some very big high-profile accidents. 3 Mile Island was a partial meltdown in 1979 in the United States. The plant cost $700 million to make, and then $1.2 billion just to clean up after this partial meltdown. And you might remember this if you've seen the movie Deadpool. This was where it was shot at the old 3 Mile Island site, was the inspiration for that. Another big accident, Chernobyl, was a full meltdown of a nuclear reactor in Russia, 1986. 30 fatalities, say only, but that's quite a bit. Far greater long-term effects. People around sick with cancer, birth defects for generations, problems in the food system, just devastating for the entire region. Not that long ago, 2011, an earthquake in Japan caused a rupture at the Fukushima nuclear reactor. And there were no immediate deaths, but there were a lot of casualties after the fact and longer term effects. Now you could ask why you're building reactors on a fault line, which is what Japan is, but it's otherwise pretty safe, except for these high profile negative accidents, which really don't give it do it a lot of favors in the public perception. It gets the public uneasy about nuclear power plant and other nuclear projects. So which source is the best? It's not really a practical question. It's not really a scientific question. That's a political question. Because governments responsive to the people, they end up making that decision. And the public are swayed by the whims of geographic politics, economic forces like rising gas prices, and then of course optics, things like nuclear power. So there's a lot of politics in the decision about which source to use, rather than it necessarily being about pragmatics and which one is the best.